Alright guys, let's look at lesson 1, which is oxidation numbers. So what is electricity and how is it formed? In electrochemical reactions, electrons are transferred from one species to another. So in order to keep track of what loses electrons and what gains them, we assign them oxidation numbers. You're familiar with oxidation numbers because they appear in your periodic table, and they are the charges that we give the element when it makes a compound, but there's a reason why, and it depends on how many electrons they transfer, if they accept electrons, give them away, so on and so forth. So there are rules, like everything in chemistry, for assigning these oxidation numbers. So let's look at these rules. First, when you have an element that's uncombined, so that means that it's an element by itself, it's not bonded with anything, they have an oxidation state of 0, and this includes those 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. That special 7. They all have an oxidation state of 0. So let's look at an example. So Na plus Cl2 gives 2 NaCl. So Na on the left is going to have an oxidation state of 0. Cl2, because it's a diatomic element, will also have an oxidation state of 0. When it forms a compound, though, the oxidation state changes. So, number 2, if an element has only one charge listed on the periodic table, then that is its oxidation number. So, for example, group 1 elements, if you're looking at a compound and I ask you to identify an oxidation state, if it's in group 1, it's always going to be +1 on the periodic table, and if it's in group 2, it's always going to be +2 on the periodic table. So, group 1, as we can see, they all have an oxidation state of +1, so when we assign them oxidation states in formulas, they're also going to be +1. Group 2, same thing. They are all +2. There's no other oxidation states on your periodic table. So again, when you assign them oxidation numbers, they're all going to have an oxidation number of +2. Number 3, if a non-metal atom is the negative ion in an ionic compound, then the top charge is listed as its oxidation state. So for example, HF and NaCl. Let's look at these two. Okay, F is going to be -1 because it only has one oxidation state on its periodic table. And Cl is also going to be -1 because it's the negative part of this ionic compound, a metal and a nonmetal, so it's going to be -1 there as well. Rule 4, H is +1 when it's acting like a metal or in front of your compound, and it's -1 when it's in the back or acting like a nonmetal. So in these two examples, H here is going to be +1 because it's acting like a metal, and H here is going to be -1 because it's acting like a nonmetal. The sum of the oxidation numbers in a compound must equal 0. It can't be anything more, anything less, must equal 0. So for example, if we have CaCl2, when we add up our oxidation numbers, they have to equal to 0. So Ca is going to be +2, Cl is going to be -1. Now, we have one Ca at a +2 charge and 2 Cl's, each with a -1 charge. So we have +2 minus -2, that equals 0. So you'd be sure to multiply the oxidation number by the number of atoms indicated by the subscript to make sure that your oxidation numbers cancel out and that everybody is happy and even. Number 6, the sum of the oxidation numbers in an ion must be equal to the charge of that ion. So for example, if we look at this, which is dichromate, dichromate has an oxidation number of -2. So we need to figure out what the total oxidation number for each of these are. Well, chromium can be +2, +3, or +6, but oxygen is always -2. So if we know that there are 7 oxygens in that formula, each have to be -2, that means that it's going to be -14 total. We have 2 chromiums. Each have to be +6 so that we get a total oxidation state of +12. So then we add +12 -14 and we get -2, which is equal to the ion charge. And number 7, if an element has more than one charge listed, use the other charges to figure it out. You're going to first assign oxidation numbers to elements with one oxidation number first. Then you're going to assign oxidation numbers which will make the compound equal 0. So if we were to look at FeCl3, Fe is going to be +3, chlorine is going to be -1, and so when we add up those charges, they equal to 0. The compound is neutral. So we're going to do these practice problems on our own tomorrow in class when we start, but I want you to try these as well as this check your understanding. All right, talk to you tomorrow.